week 5. And to illustrate what a flowchart is, I found this on iFunny, and it made me laugh because my son despises the word moist. And apparently there are more people like him in this world. So this one says the word moist, and it flows into, are you using it to describe cupcakes? And if you say yes, then they say, oh cool, let's have some cupcakes, because moist cake is delicious, I think. And if it's no, then they say that word is gross, now we aren't friends. And this one is just a comic, so it doesn't even follow the correct conventions, but it just gives you a sort of sense as to what a flow chart looks like. And this is lesson 5-2, but actually it also comes into 5-1 as well, because 5-1 always gives us the reading and programming exercises. And one of the programming exercises in chapter 6, the first one, 6-1, needs to, you're going to end up working on a flow on the program for the flow chart that's in the book. So it sort of is a combination. So I want you to kind of look at them both together and get them both done at the same time, and maybe lop something off earlier this weekend so you have less to do later on in the week. Okay, so first of all, a flow chart is a chart or a diagram of the flow or sequence of your program. So basically, when you use a flow chart, you create a graphical or visual representation of your program, and it shows the steps of your program from start to finish. So it just sort of shows how the program flows, not every little exact detail. It's more of an overview picture. And it's really important to know that each shape has a meaning. And I want you to pay particular attention to this, because as we've done with pretty much all of our exercises, when we learn a new concept, you are going to have to implement it. So this week, you're only reading the flow chart, but you're going to pretty soon have to create your own flow chart. So I want you to pay attention to how it's done. So the first thing you have is a terminal symbol, and terminals are the start and the end. They only have one flow in and one flow out. So this one, so start, it's flowing out, starts from the start, and then flow in from the end. So it's going to go into the end. So if you think about terminal like an airport, you have to go to the terminal or to fly out. And then at the end, you also go to the terminal to get your luggage. So everything starts and stops at the terminal. So input and output symbols, those are the parallelograms. So if you like sort of tip your rectangle on its side, you sort of squish one side in. And these ones have one flow in and one flow out. And you use this when you're either taking in or sending information out of your program. So user input would be a way that you'd use the symbol for user input. And then also any output that you're going to do, like print statements, print line statements. I guess it shouldn't say user, it just should say output. And that is for the input-output symbol. And then the decision symbol, I like to call it decision diamond. A lot of my students have trouble remembering this one. So decision diamond, both start with D. It's a nice alliteration there. And this is for decision making in a program. So you're going to have one flow in, and you're going to have two flows out, because you're going to either have a yes and a no, or a true and a false. So in this instance, is int equal to 3? So is that variable equal to 3? Nope. Then you go one way, and yes goes another way. The process symbol is really for computational steps of a program. So this is any time that you're setting something equal. If you're doing any type of math, then you're going to put it inside this. So it's sort of like internal things that are happening inside the computer that no one sees. You can just put in a regular rectangle. These also have one flow in and one flow out. And finally, we have these predefined process symbols. And so this shows that there's another method in your program. So you're calling another method when you see this. And then there'd be a separate flowchart for that method. And it's a rectangle, but it's like a rectangle within a rectangle. So you have little stripes on the side. So I have done a sample flowchart for the area problem that you guys originally did in exercise 4.2, and then you revamped it. And so this just assumes that, this flowchart works for either program. So the program would start, and it's going to read the area. So we're going to get some user input, which is why it's that parallelogram, and the user is going to either tell us it's 1, 2, 3, or 0, depending upon what they want the area calculated on. So my first test is to say, okay, is the area equal to 0? So did they put that they wanted 0, which means they don't want an area? So if I say yes, then they're going to get a message. So this is user output. Same parallelogram. I colored it different colors to help us visualize. And it's going to say, come back when you want an area calculated. It's just going to be on the screen for them. And then the program terminates because I have that return in there and it's done. So the next piece is I'm going to check to see if the area is equal to 1. If it is equal to 1, then I'm going to ask them for a base. So this is again user input. So it's the same shape parallelogram, but I changed the color. So I'm going to read the base. They're going to give me an input. I'm going to read the height that they're going to give me, and then I'm going to call the method area triangle. So I'm going to take the data, or I'm going to go over here and then for area triangle, I'm going to do a calculation. So we know in our code that I have parameters in here, so this doesn't show all the parameters or anything like that I'm taking in, but it gives the flow of the program. I'm going to do this calculation, and then there's going to be an output. I'm going to print the area for the user. Then I pop back over here, and there's nothing else in this line of code, so I just go right and I end my program. So if I start it again, and I read the input that the user gives me, and this time the user says 3, or actually this user says 2, so is 2, it's not equal to 0, it's not equal to 1, oh, but it is equal to 2. So I'm going to get the radius input from the user, I'm going to call the area circle method, I'm going to go over here, and then I'm going to do a calculation, and I'm going to do pi times radius squared, I'm going to print the area of the circle, pop back over here, and there's nothing else to do, so my program ends. I'm going to run through the program again. This time I'm going to do an input of 3 for the area. So it's not equal to 0. It's not equal to 1. So I'm going down the no route. It's not equal to 2. Is the area equal to 3? Yes, it is. So now I'm going to get length from the user, width from the user, and then I'm going to call the area rectangle method. So I go over here, and the area rectangle method will do a calculation for me. It's going to do length times width. It's going to print the area. I pop back here. There's nothing else left, and so then I end my program. And that is how a flowchart works on a program that you're already familiar with. So now you have a picture of a flowchart, and it has to do with a factorial. So I just want to remind everyone what a factorial is because, again, you might have forgotten. I forgot until I started programming again, and I'm like, oh yes, I remember I learned that a long time ago. So a factorial, it's represented, so if I was going to do 5 factorial, I would have the number 5 and the exclamation point next to it. So that means you want a factorial, and that just means you're going to multiply 5 times 4 times 3 times 2 times 1. So you just keep going down the line until you get to 1. So if it was 6 factorial, then it would be 6 times 5 times 4 times 3 times 2 times 1. So the answer of factorial 5 should give us 120. So I always like to go through my code and test it when I'm doing coding with something that I know the answer is going to be. So I'm going to do one for 5, which is like the in your book. And I also want to remind you about the commutative property of multiplication. So we originally, when I said factorial, it's 5 times 4 times 3 times 2 times 1. But because we know in multiplication you can switch the order around, 1 times 2 times 3 times 4 times 5 also is going to give us 120. Sometimes it's easier to program a certain way, so that's why I wanted to talk to you about that. And the way that the flowchart is, it's doing the 5 times, it's starting at 1. So here is the factorial flowchart. We're going to just walk through it so you can see how to read a flowchart. So we're going to start, and then input n is going to be whatever the user inputs, and we're going to do a 5 for that because that, again, I like to test things out. So I want to do something that I know the answer to, and then I can play with other things later on. So m is going to be set equal to 1, and f is going to be set equal to 1. So I put n for number so I could remember, so because it's n factorial. So whatever number you input, this is going to work for any number. And then m is going to be the loop, and I was thinking of m for many because you're going to go, how many times you're going through this loop, because it's going to have a little counter on it. And then f is for the factorial, because that's going to be in the end what the answer is going to be, because they put f equals here. So we have m is equal to 1, and we have f is equal to 1 per our program. So now we go down to this line of code because this tells us where the flow is. So f is equal to f times m. And this is something that we are learning this week, is that we can change the value of a variable. So once we set the variable, it's already been created. I don't have to do anything, but I can change the value of it, and this mathematical operation would change the value of it. So instead of factorial being 1, now it's going to be f times m. So actually, it is still going to be 1, but it was replaced by a different value. So I want you to understand that original one is gone, and this new one is a result of this calculation. So now we pop down to here of our code, and it says, does m equal n? So does m equal n? Well, no, m is 1 and n is 5, so no. So I have to go from the decision diamond over here to the no. Now there's a new calculation, so m is going to be equal to m plus 1. So m is 1 right now, so m is going to be 1 plus 1, so it's now going to be 2. And there's only one flow here, so I have to go up here, and now I'm back to f equals f times m. So I just reset for what the values are, so we're on our new loop. So we're going to say, okay, f is equal to f times m. So 1 times 2 is equal to 2. So that 1 goes away, and now I have a 2. Does m equal n? 2 does not equal 5. No. So now m equals m plus 1. So 2 equals 2 plus 1. So it's going to be now 3. And I go back to the top. All right, so here we go. Here's our third iteration. This is our third time through the loop. We learned about that word iteration, so it's how many times we're repeating a process. So we're just going through this process. So we're on our third iteration right now. And these are the values that are in our field. So you can imagine it's one bucket. I'm just showing each iteration here. So we have f is equal to 2, m is equal to 3 right now, and n is still equal to 5. We haven't changed n. There's no alterations of n in this entire program. Okay, so now f is equal to f times m. So f times m, 2 times 3 is 6. Does m equal n? 3 does not equal 5. Nope. So m equals m plus 1. So 3 plus 1 is now 4. And we go back to the top for our next iteration. Okay, so 6 times 4, I have this memorized now, is 24. And 4 does not equal 5. So then I'm saying, so the m is equal to what m is now, which is 4 plus 1. So this is going to change to 5. And then we go back up for our next iteration. And here we go. F times m, 24 times 5 gives us 120. Now we say, does m equal n? Oh, yes, it does. It does. It does. So now we're going out. We're not going to the no anymore. We're going down to yes. And we're going to give an output of f. So our output of f is 120. So we print out 120, and that is the end of our code. That's how you read a flowchart, and that's how you go through a loop. So your loop will look different in your code, but it's the exact same process. So I hope that was helpful. And now you're going to think about your lesson. So lesson 5-2, you're going to write a pseudocode. So you're just going to put in general words. You're just going to put a fake code, and there's an example in your book, in your lesson 5-2, what the pseudocode looks like. And it's just basically code written in English. You're just walking through in English what's happening in your code. And then you're also going to do exercise 6.1, and that's in the end of chapter 6 in your book. And there's a factorial project that you're going to work on. So you're basically going to code what you just saw in that flow chart. And that's going to be worth 25 points. And then the pseudocode is worth 30 points. So good luck, get this done early, and that way you'll have more time to work on your code. We're going to try and balance some time management. If you have any questions, send me a message or post something to the group. Thanks.